Welcome to Graphing Rational Functions Part 2. If you watched Part 1, that was a quick overview of everything except for slant asymptotes. Part 2 is actually not going to have anything to do with slant asymptotes either. It's just going to be what are the different types of situations that we've been seeing when it comes to graphing. So in that previous one, we graphed a hyperbola. That's the basic, the easiest one there is. The next thing, what I'm going to do is I'm really just going to go through an example. I'm not going to do much of it too slowly. I just want to kind of do the end part slowly. So if you still don't know how to find x-intercepts, y-intercepts, etc., you should watch the first video or come see me after school. So our example is going to be, let's do y equals x squared plus 2 over x squared, minus 4. Okay. So same thing as always, I'm going to find all my important information, but I'm just going to do it really quickly. So x-intercept, none. Y-intercept, plug in my zeros, and I get negative 1/2, so 0 comma, negative 1/2. Vertical asymptote, denominator equal to 0, x equals plus or minus 2. Oh, there's two of them. And horizontal asymptote, these two exponents are equal, so y equals 1. Now, I'm going to plot what I know on my graph. 1, 2, 3, 1, 2, 3. Okay, and I know I have vertical asymptotes at 2 and negative 2. Horizontal asymptote at y equals 1. I have a y-intercept at 0 comma negative 1/2. And then I don't have any x-intercepts. Okay? This totally happens. It actually happened on, I think, the quiz you just took. And it's a very, very similar question. Now, the next thing is, since I have most of the information, I do still need more of a graph. This one point is not cutting it. So what you have to do is you have to make an XY table for all of the other possible points. So let's do that. I have my y equals x squared plus 2 over x squared minus 4, and I'm going to make an xy table. The only point that I actually knew was at 0, and it was 0 comma negative 1/2. I also know that at my asymptotes, negative 2 and 2, it's undefined. Doesn't exist. So that means on every single side of negative 2 and 2, I have to plug in some values. So I'm going to try negative 4 and negative 3, and 3 and 4. The nice thing about the graph I chose is it's totally symmetric, so I really only need to do 3 and 4, and then I can just plug in for negative 3 and negative 4. Now I say that phrase all the time. If you still don't know what symmetric means, come talk to me, but it's just the fact that they're both x squared, so doing 4 squared is the same as negative 4 squared, and it's all the same. So let's do it. 4 squared is 16 and 2 is 18, divided by 4 squared is 16 minus 4 is 12. Simplify the both divisible by 6, so 3/4. 3/4. Same thing with negative 3 and 3. 3 squared is 9 and 2 is 11. 9 minus 4 is 5. 11/5. Main thing that you need to know, this is a little bit bigger than 2. Okay, and 3/4 you should know is 0.75. Now, the other thing that's tricky is because of the way the graph looks, okay, we have these vertical asymptotes, and I know this point, it's a nice thing to plug in 1 and negative 1 as well, just to have some more points in between, because you should have an idea of what this graph looks like already, but a lot of you might not. So I plug in negative 1, or 1 and negative 1. I get 1 plus 2 is 3, divided by 1 minus 4, which is negative 3, so negative 1 for both. So I'm at negative 1 here, negative 1 here. When I draw my graph on that side, all I have to do is connect my dots. And it's this parabola-ish looking shape. It is not a parabola, but it kind of looks like one. And notice, you're not done. Okay, we still have these outside regions outside of the vertical asymptotes. We now plug in the other points we know. Negative 4 is at 0.75. Sorry, I think I did something wrong. Oh. Sorry, teachers are allowed to mess up too. Some of you probably noticed it and were like killing yourselves for 3 minutes. Like, why is she not fixing that? 3 halves. Okay, so so you notice how I figured out just by looking at my points that this was going to be wrong. So I take my 3 and 4 and I plug them in. So 3 halves is 1.5. Oops, wrong one. 3 halves is 1.5. 3 halves is 1.5. Oh, wrong one again. Okay. Then 11 fifths we said is a little bit bigger than 2. 11 fifths is a little bit bigger than 2. And I connect my dots. Again, asymptotes mean that's what they're approaching. So you should draw your arrow so that it's getting closer and closer to both the vertical and horizontal asymptotes. Notice again in the middle, this graph does not have to get close to the horizontal asymptote because it's the middle. Okay, horizontal asymptote means what are the ends of the graph doing. So there's one graph that you've definitely seen a bunch of, and so there it is. There are a couple of other types of this graph that we could see. We don't see too many of them, but there are a lot of different ones we could see. Another type of graph that we saw a couple of times. Okay, let's graph y equals, let's see. How about we do, let's do 2x over x squared plus 1. 2x over x squared plus 1, find all our information. Now, if you want to try it on your own first, then push pause on me, do it, and then come back. However, here we go. X-intercept, set the numerator equal to 0, 0, 0. Y-intercept, plug in 0, it's 0, 0. Vertical asymptote, none. Horizontal asymptote, it's not none, it's y equals 0. So I draw my graph. Horizontal asymptote is the only thing I got going, and notice that's 0. When I make my table of values, since there's no x-intercept, I'm going to plug in a couple of points on either side of the vertical asymptote to see what's going on. And notice it's not symmetric anymore, so I do actually have to plug in a couple of them. So I'm going to try to do -3, -2, -1, and then maybe I'll do 3, 2, or 1, 2, 3. -6 over 9 and 1 is 10, so divide both by 2, -3 fifths. So I'm like at -3 fifths. -2 is -4. 2 times 2 is 4 is 1. -4 fifths. -1, so I get -2. 1 and 1 is 2, so that's -1. Alright, so what I'm realizing is I actually did one of the ones that I was talking about before, which is tricky that we haven't done. So what I'm looking at is this looks like the graph is going to start going this way, but that's impossible because it doesn't have a vertical asymptote and it's supposed to go through the 0, 0 spot. So what I decided is let's plug in -1/2 and see what's going on. If you plug in -1/2, you get -4 fifths. Well, -4 fifths, we've seen that one already. It's right here. And so what's going on with this graph is actually a similar shape that I drew before, but I'm going to plug in the rest of the points so you can see it. Over here, I've got 2 over 1 and 1 is 2, so +1. Okay, plug in 2, and I get +4 fifths. Plug in 3, I get +3 fifths. And if I plug in 1/2 again, I get +4 fifths. So this is that graph that I was talking about that looks like this. Obviously I didn't connect my dots very well. Sorry, I'm using an iPad. Okay, so in the middle, it's totally allowed to cross 0, 0, but the rest of the graphs are approaching the horizontal asymptote. Now, you might be saying, well, how am I supposed to know that? Like, how would I, when I'm just looking at it, figure out that that's what's going to happen here? Well, you should at least draw me as best as possible that it's approaching the horizontal asymptote. Realize that it's got to go through 0, 0. Realize you should have plotted at least 3 or 2 of these points, and then kind of guess it as the rest of it goes. If you have no clue, at least you have all of these correct, all of your points correct, your approaching asymptotes correct. The most you could lose is points on drawing the final touches of the graph, which, for example, on the quiz, a 25-point question, it was only about 9 of the points. Now, I know that sounds like a lot, but if your graph is entirely wrong, losing 9 points on a 25-point question is not that bad. Okay? So it's going to take some practice, but it really is all the same really important information drawn into a picture. So I'm actually going to do one more graph. It's kind of a long video, so if you want to stop watching, you can stop watching. If you want to fast forward or whatever it is you're going to do, go for it. But we're going to do one final example, and then we're going to be done. Again, we're not doing slant asymptotes yet. That'll be a part 3 video. So the last one we're going to do is one that's come up a couple of times. I'm going to do -4 over x squared plus 2. -4 over x squared plus 2 has the distinct pleasure of having no x-intercepts. The y-intercept, however, does exist, and that's 0, -2. It also has no vertical asymptotes. Horizontal asymptote is y equals 0. So your horizontal asymptote and your y-intercept are all you get to draw. What a shame. 0, -2. Horizontal is at 0. And all I have left is just like that last example, I can only make xy tables. Now this one, because it's only an x squared, it is symmetric, so I can just plug in some positive numbers and then go from there. So 1, 2, 3, how about? -4 over 1 plus 2 is -4/3. So at 1, I'm at -4/3, and at -1, I'm also at -4/3. At 2, -4 over 4 plus 2 is 6, so -4/6, which is -2/3. Plot myself at -2/3. Last one is 3. I have -4 over 9 plus 2 is 11. What a hideous number. I'm very upset that I did that, but who cares? -4/11ths, -4/11ths. And this should look familiar because we've done a couple of them. It's this little upside down mountainy looking thing where it goes through its y-intercept and it approaches horizontal asymptote but never actually crosses. The last example was an example where it does cross, but again, at the ends, it's never going to cross. And how do I know it doesn't cross anywhere? No x-intercepts. Okay? So those are the basic types of examples you could see that don't involve slant asymptotes. Okay? When we do ones with slant asymptotes, you'll have no horizontal asymptote, and we do slant asymptotes because our equations will only be one variable, like one exponent away from each other. So we'll have like x cubes and x squareds, or x squareds and x's, and so on. Okay, so I hope that helped for anyone who's forgotten everything, and if you want to see the slant asymptote video, you're going to have to check out part 3.